I'm going to do what I call continuous improvement, and they bumped me from 15 minutes to 45. Thank you very much, Nisa. And one of the things on your website, you're telling me you're a professional heavy capacity industrial weighing association that serves you. What I've been doing, I've been finding myself into heavy capacity, but I started out in small capacity. And so I will have both of them if you don't mind. So I first of all want to, a little bit about myself. I started out in this industry about 40 years ago. The industry I'm talking about is the asphalt mix industry, the one that put the asphalt on your roads. And so anyhow, it's been a long struggle. This is my family. They put up with a lot of stuff that I wanted to do. And so I just thought I should be taking some time to thank all of them for allowing me to be where I'm at. I call myself Easy Flow weighing systems. You see a scale there, impact scale, but the scale is just part of it. We were talking about correctness and accuracy. So having in the system is something that is very much part of correctness. On the left over there shows a drum mix plant and an asphalt plant, and we started out in the industry, or I did, with batch plants. You got concrete batch plants and then you got asphalt batch plants, but we were doing such high production with asphalt that they actually wanted to do something a little bit more that could take on the kind of production they were looking at. And they went to continuous mix plants, and so continuous mix plants means that you are blending material on the fly as it goes in. And when they first started doing this, they were blending all this stuff in volumetrically, and I'm going, hey, you guys got a problem, because we're really not getting the quality of material that you're getting out there. So it got me on a pursuit of weighing material on the fly. And then the fellow there in the center, he and I go way back. That's that Jeremy Dade guy. And part of what I was doing with equipment and service I was doing is it's one thing to give them a piece of equipment, but if they don't use it right, well then that's a problem. So then I started getting into training curriculum, and so he's showing there some training curriculum going on right there. He was actually one of my first students here in Colorado, and he's been through my classes several times. This guy has just got so much energy, and he's so enthusiastic. A lot of times when I put on these little workshops, everybody, the room populates from the front to the back, or from the back to the front. But he was right there in the front. And then he wanted to come to work for me. He's in Grand Junction. I'm from Minnesota. I'm going, I'm not quite sure. Your family making that change or that culture shock. I'm not quite sure if they can handle all that. So I really at this point in time can't do that. But then someone else recognized him as well, and that is the owner that wanted to sell Western Slope scales. And he says, this guy has got so much potential, and he's probably a candidate. And the first chance, and so when it was offered to him, the first thing he did is give me a call, Clarence, I'm going to be buying this Western Slope scales. And I was, well, terrific. I said, now I can start using them on different projects that I'm using. So that really made me feel good about things. And then there on the right, he was going to be here. He's your new member. And he couldn't make it. The reason he couldn't make it because the day before he was supposed to come here on Sunday, Billie Jean, his wife, broke her leg on a road bike, on a dirt bike. And so they couldn't make it. And so I just want to be able to introduce to you this guy right here. This is Jeremy, and Jerry, we miss you, but next time. And then other people that help me do what I do. The guy on the right there is David. He's been with me for 10 years. When he first got in the industry, he knew absolutely nothing. He probably had a difficult time operating a screwdriver and pliers, but right now he's my main guy, manufacturing, customer service. As he has been paying attention away, he is just so much, means so much to me. So thank you very much, David. And now this gives you a little bit of a look about where I have been at. And you're going, well, if you look at that, and I kind of brag to people, I've got the widest selection of continuous wave scales probably on the planet. And the reason, and the way that happened is because I am willing to take on custom work. They send me their applications, and when I see those applications, I say, well, I don't have anything currently that will take that, but maybe I can modify something. So if you see the scales at the top, I call that my small mouth, and it's an impact scale. And there's a plate that hangs from that scale. And as material comes from the right to left, it hits that scale or that plate and pushes back against a load cell. And you see that one there that we have below, this here shows that yellow and red one. This is something I can put at the end of a conveyor or at a feeder. Whereas the one below that, the one that says conveyor discharge, I can be weighing material coming off the end of a belt scale. But sometimes, or off of a belt. Then the one below that, the one that is red with the grids, I said, you know, it'd be nice to be able to weigh some stuff, but I'm retrofitting. They don't really give you too much room in order to put your flow scale in because this is gravity fed. And then below that point, we see a weight loss, which was, it's a non-contact, but we need flow. And typically what we were doing at the asphalt plant is where we were doing things volumetrically as we were blending stuff, but then they started to put recycled asphalt shingles into the bin, and that presented its own problem as well that I can get into later. Then there's the process controls that we have to do, and so this completes the system as long as we got the right training for it. I got to a point where people weren't believing in my scales, so I started building my own feeders. And in the asphalt industry, they have a need for special projects to have some of these feeders available, so I made them available. And I added my scales to them. So now I'm doing DOT work all over North America with that stuff. So this is where I'm going with all this. But I'm also looking at raising the bar, raising what I have done. I'm looking at continuous improvement. Can we do better? And it just kind of dawned on me a few months it did. And so when we had Aaron talking here about correctness, I mean, that is accuracy I understand, but correctness I don't. What do you mean by correctness? And correctness, then it gave me an idea of, if you do calibrate at one time, does it maintain its calibration, etc. That kind of thing. So, and then you see on the bottom, I really went to a lot of trouble to train people, and I thought that was really important. So this is kind of what I've been doing for the last 40, 50 years. Okay, and so here's Jeremy. We're at we're doing what we like to do best, is like mingle with you guys. And then so I want to start talking a little about how we can compete against the heavy capacity scales. So heavy capacity scales are very expensive, and sometimes you have applications that you could do if you had something that wasn't so expensive. So here we're looking at what we can do at the end of these loading conveyors into your barges, your rails, your trucks, and consequently you're just weighing the net stuff and not the entire gross. And so we looked at what would it take to develop something like that. We had a customer that says, if you can make me one and that passes it, I'll give you an order for 10. Well, he did give me an order for 10, and this is what we had to do in order to get it. Like we had to be planting a scale at the end of this conveyor, or a conveyor like this. And then, as you can see, these are transloaders, and they have belt scales in them. So sometimes they end up using them instead of using your rail scales, etc. And what I'm seeing with these transloaders, they're taking that belt scale and they're burying that inside an enclosure. I mean, I can't even get at it if I want to do something with it. And so I thought that to be a problem. And then also you can see the string lining going on there in this there at the belt scale. I mean, this is really very in order to get the accuracy, the best accuracy you want to get. All your rollers are supposed to be square with each other and all on the same level, and all from side to side as well. And if anything is off, it's going to start throwing off your linearity on your belt scales. And that gets to be a problem because all of a sudden you're not getting the accuracy you're looking for. Case in point, this happened in the Dells. I had one of my guys go out there and put a belt scale in. He's calling me back, Clarence, I can't get it into the plus or minus 0.5% we were looking for. They're from 25% to 100% flow rate. And so then I end up going out there. And when I ended up going out there, I'm just looking at the belt. And as the belt's going up, I'm seeing one roller. All the rollers are turning the same speed except for one roller on one side was not. That means it wasn't contacting the belt like the others were. That means it was off a little bit. I said, stop the show. And from that point, we moved it over just a little bit, started it up where it was even on both sides, and it fell right into place. So it does make a difference. It's hard to keep these things maintained that way. And so what my continuous improvement thing is at the end of what I'm shooting for here is going to take that into account, that sometimes when things mechanically go wrong, it will correct for that. So this is what I'm shooting for. And so now I'm not sure what I'm trying to say there, but we're just showing that we're showing a belt in the belt scale in the middle of a belt. So if you're weighing something, you have a totalizer on that belt scale, and this is how you know when to stop the feed. But the thing is, when you stop the feed, you're stopping the feed with a belt half full of material that's been weighed that didn't go into the vessel that you had sent it into, FYI. So that was another thing that I kind of found to be a problem. And then they're also talking about gravity take-ups. At the asphalt plant, we put gravity take-ups. We want to keep a tight tension, same tension on all the time. And when you move these transloads around, they're not going to be having something like that hanging from the end of that conveyor like that. So I just transpose that on there and say, this is something they should have for accuracy purposes, but they don't. And so that's what that gravity take-up looks like there as well. So now we're looking at planting something at the end. Something at the end, as the material falls off the conveyor back into your vessel, that's where it's being weighed. And so consequently, you don't have that half full of weighed material. And this is what we ended up starting doing. I think it was you, Ryan Fox, who told me about an application you had in Illinois someplace, and you wanted to load trucks with grain. And I'm seeing that the scales, I didn't have the scale here at the time. I go, in order to be weighing that, I'm going to be restricting things. Consequently, it's not going to be filling these trucks as quickly as I wanted to. So I thought that was a problem. But something like this could work out in that situation. And how this thing here works is that stack on the left, the middle component of that, that's what I call my weigh basket. And then I tie load cells to each side of that. And then, and so as material hits that middle plate there, or that middle basket there, it pushes down on your load cell, giving you the impact. The device on top there funnels all the material that would have gone in between those weigh bars, I call them, on the basket, and funnels them to the weigh basket so we catch it all. So here we are. David's putting this here together. And here you can see he's, what you don't see there, he's holding a rate indicator, but we got 3 test weights there hanging. And as you hang out one test weight, you might say 100 tons per hour. 2 test weights should be 200 tons per hour. 3 test weights should be 300 tons per hour. Things you guys know. And here we're just kind of with the engineer, the mechanical engineer helping them out. And this is, now we've got this here at the end of a conveyor. You can see from the inside right there how the material at the end of the belt might fall into it. And then you're seeing material flowing through it. And that's kind of what we're doing there. And so we're looking at different ways to put them on different transloaders and loading trucks. And so now this takes us to how do we calibrate a belt scale or a continuous weight scale. And it's called the material calibration. You run the material through it that you're going to be weighing, and then you capture that material. And after you capture that material, you compare it to what the scale totalizer is going to tell you. So there on the side, you can see we got 3 entries here. Typically what I tell these people is that I'm looking for, first of all, repeatability. If there's an error that is being caused in our scale, if it's repeatable, then after that point, we can linearize that. And so I typically do about 3 tests, and if I have a tight shot group, just like when you sight in a rifle, do I have a tight shot group? If you do, then you know how to change your windage and elevation on that, and that's what we're doing here as well. Now, in this one in particular, I didn't do it for the tight shot group because I got 3 different rates there that we're going at. We got scale rates, one at 313 on ton per hour, one at 125, and one at 500. So basically, we were shooting to see how accurate we could do between 125 ton per hour and 500. So what I did in the first place, that in the middle at 313, this is where I had did my material calibration, adjusted my span accordingly, and then after that point you might see what you get at 125 and 500 to see how far off you're at. So that was the idea about behind this. So this is the spreadsheet right here. It's this spreadsheet we're going to start working from. This is going to be what's going to be the key in how to do the correctness that and the accuracy that Aaron Yanker was talking about. And right now, if you look at this, you're saying, okay, I am trying to get within plus or minus 0.5%. But you can see we did 3 tests, and they're all a little bit high. So what I tell the students when I train them in, I'm saying, well, okay, I guess this ain't going to work because they're too high. Or if you're going to change span, if you just have one span, where would you change it and how much would you change it? So you would change it like, if you look at where it says 313 ton per hour, that is about 0.6, 0.7% too high compared to where you want to be at 0. So if you change your span, decrease it down about 0.7, it's going to bring everything else there in the range you're looking for. So that works out good for us. Terrific. So what I wanted to do is I even want to get better than that. I would like to see if I can, how close I can get to be where it's really at 0 all the time. So those are lofty expectations and goals, but I'm going to push for it anyhow. Now you might see something like this, you go, okay, what am I going to do with that? And if you just have one span, you can't do anything about that. Some scale integrators do have, and mine does too, but it's very cumbersome that you can linearize this out. And then also, that data isn't being saved and used as history. So just by doing the spreadsheet like we did before, wasn't getting the job done as far as I was concerned. But you can see right now, if you had this kind of a 3-point test, 125, 313, 500, and you want plus or minus 0.5%, that ain't gonna happen here. So I tell them, okay, you either got to string line your belt scale or whatever you got to do, check your load cell, those kind of things, hang some test weights one after another, and if you still can't get it in, well, you're just out of luck. So from that point, I says, well, I made a device. It's this 824 right here. This is my scale indicator, or my totalizer at the same time. And so this is typically all I ended up running with. But now I added a gadget on top. It's a PLC with an HMI, and so now we're experienced at doing that and very successful at doing it at the same time. So as we're going through this, I'm going, this could add, I could use this kind of technology to take us to the next step in what it's going to take to do the correctness that I'm looking for, because we're going to have that kind of a display available, and we're going to be putting some stuff in there. It's going to have some history, and consequently that history is going to correct the reading I was getting from my scale indicator. So I'll talk more about this guy right here, what we're doing with our weight loss scale controller, but it's the fact that this is the device you're going to be adding something like this to what you're doing when you're doing material calibrations. Just as I showed you, we had material calibrations manually entering it. Now we're doing it more automatically, and we've got more information that we're putting into, and we're also drawing some information from the integrator. And so some of the things that were taken from the integrator, of course, is what the flow rate was. But also we're doing our material calibration. So we end up taking in consideration what our reference scale was, what the tear weight was, that goes in here. We're comparing now what our rate ton per hour that came off the scale indicator. That's wrong. It's assuming it's right. But now we're looking at what really did happen, because we're comparing it to a known reference. And consequently, now we're going to change the span based on that ratio, how far that error was off, and it's going to come up with the new corrected span, so that now you're getting the information, the truth you were looking for all along. So there may be some tests that we have that will accept them. It might be that we know we screwed up the test, but it's been logged in already. We can accept it, or we can reject it. So we got different feeder speeds that we're going to go to, and then after we so since we want to see an entire flow rate, we're going to do it at 30% speed, 60%, 90% speed, and you're going to see the error is going to be off by some amount, and it's going to correct for that. So basically what we're seeing is our red boxes here are telling us what our scale indicator was saying, but this right here, the green ones, is what your reference scale history was telling you that was going on, and you can see the difference. This gives us a factor now that we can correct that span with. This is what the run screen is going to look like. It's pretty simple. It's just a scale indicator. I got time, I got my tons per hour. I got how much went through there. I got long-term, short-term. I also want to start logging in temperature. Temperature drift is a little bit of a problem. So since we're in the run screen, we says, well, maybe we want to calibrate. So if we want to calibrate, this screen here comes up. And so if you want to start your calibrate, well, then you hit the start button right here. A timer goes off for as long as what your test is going to be. So that kind of material that elapsed had gone through there in that amount of time, you can figure out what your flow rate is. So we're not only improving the flow rate accuracy, we're also going to improve the totalizer by the same amount. So consequently, so if you hit your start button, then you're going to go into the calibrate mode. And if you go in the calibrate mode, now it starts that timer that we're talking about. And it starts clicking away. And then you're going to end up hitting stop. And then after that point, when you did that, this is okay. It's going to do the computation of what the flow rate it was and how much pounds and tons that had gone through there. But also now we put in our reference scale numbers, how much we weighed in a barrel, how much we weighed in a truck. And then we fill that in. And then when that gets filled in, it tells you now what you're on the far right, or if you take a look at the bottom, where it says total idle pounds and net pounds, this is going to, your ratio one against the other, you know what your, how far you were off. It tells you what your error was. You're at 0.374. That's within the 0.5% you're looking for, so now you're happy. So you're probably going to accept that. So once you accept it, and you did 3 of them, one's at 0.374, one's at 0.046, and one's at 0.39. That's good. It's going to remember that. It knows when you're at that flow rate. We're going to use that span because this was the current span, and this is what it's changing the span to, and now it is drawing a line through there as it goes through all the different tests to give you the curve you're looking for, to multiply that times what your span is at for that particular rate. So as you can see, this is what we're looking for, and here we had a 3-point calibration again. Now he says, okay, we're at 30% feeder speed. Now we do 60% feeder speed. Now you do it again. And we're doing what we can to make all of these user-friendly to Beltway scale integrators and Sharkway, so that this could be something that you could add as a feature to give you the better accuracy you're looking for. So that gives you a spin there on what what I'm doing for that I would like to see, and we're in the process of building that right now. And this looks so doable, and it's so easy just to add to an existing situation. So you're seeing here where I first started out with impact scales, and then I found some other applications that need to do. If you take a look at the bottom left, that's the first scale I did right there. That was kind of an interesting scenario on what we had done there. The one in yellow there's our scale. We're weighing fiber at 2 pounds a cubic foot, at 20 pounds per minute, and this is what's going into your roads. And it's got to work, because the DOT would be putting me out of business real quick. So as you can see here, as over a period of time, I started racking up the jobs, and I really kind of enjoyed that. There are ways that we can retrofit this, or sometimes we can, in new situations. These here are existing situations, and here we have a whey pod. You can see there on the far left we have a whey pod there being filled by the silo, and but they were not happy in how that whey pod was working for them. And they said, what happened if we took that whey pod out and you used your scale? Well, all you have to do is the vane feeder on the bottom of your whey pod, put it up on top there where your silo is, and then control the flow that way. And so you can see that, and they've been very happy with that. Here's applications we're doing: mineral filler, hydrated lime, fly ash, crushed limestone, whatever. And now we're, this is a situation in Florida where they're saying, Clarence, we got some sand in the silo. We want to be dumping into our mixing truck, but we got to weigh it. There's asphalt in there. And so, and I said, well, I see what you got here in the distance we have here. I don't think I can get a red scale under that thing in order to get the job done, but I do have something on the shelf I haven't tried before. And if this works for you, well, then bada bing, bada boom. Otherwise, you have to remember that after that point, we're going to have to drain. If that doesn't work, we drain the silo, and then we have to raise it up and then put in the scale. I says, and it worked out terrific for them. So anyhow, it's these guys sometimes get to be my my testers on things. Here we're showing that we're putting another scale up there. This is in El Paso, Texas, and now that scale was a little bit too tall for some applications. Right here, we got this thing down to 4 inches tall. So this gave us enough room in a screening plan at frac sand that we could actually help them keep the production at the rate that they wanted to go at, and that really did help them out a little bit too. And here's the red device right here. This here tells us is a one going from a vane feeder up a scale. And then now we've got recycled asphalt shingles. Now this stuff is kind of interesting because if you try to use this volumetric, the density changes. So anyhow, that was good that we put this scale, and basically it's the same kind of impact scale we had, but it's just wider. And we put panels across it to keep the wind out. And so we were weighing that, but we had a little bit more buildup of this material on the on our scale plate than really worked out good for us. So then we this is our feeder scale right here. So, and then there's situations where we got very little room to be putting something in. So we made a scale there that we can slide that in right there next to a feeder, and put that in. This is recycled asphalt shingles. Recycled asphalt shingles, nobody really wants to be around because you got all this in the shingles. You got pieces of oh, help me out here, fiberglass. And it's floating in the air. It's getting in by people's necks, and no one wants to be working with this. And so it was to a point where I first put this in, that the people that was using it, and then on top of that, asphalt shingles were sticking to this. And when I come to see them again, my scale here was sitting out there in the ditch, and they didn't want it. And I go, oh no, I don't want to give you your money back yet, because I got another idea going on in my head that I think you guys can benefit from. And that was this thing right here. So this is actually their bin that the feeder scale was on, and but we did something different. We jacked up the bin there at the dividing point, put load cells in there, set that baby back down again, and now we were weighing the load. And so what was going on? See, the problem here is that recycled asphalt shingles changes in density, and putting it into a volumetric feeder really isn't all that smart, because they were finding out this ain't working for us, and so. We put the thing on load cells, and now we're getting a weight depletion. And what really worked out good for us here, I thought I had something there. I'll back up. What that really worked out good for us is that earth to clearance was that as we're weighing this right here. Their volumetric single went to their blending control system. So their blending control system had a bunch of volumetric signals going to that. And without making any hardware software changes to it, that was important to me. So what I did is I took their volumetric pulses that was going to their blending control, sent it to my weight loss controller, and so now my weight loss controller up here, you can see it shows that it's telling us what our volumetric rate is, and at the same time I'm developing a scale rate as well. And now you're going to see the difference between them, and by doing so you're going to be coming up with, I know you're hard to see there, but it's going to come up with a ratio on how far off they are. So with your incoming volumetric, it's multiplying that time that ratio that we had, and so it is increasing or decreasing to what it should be in the same language the blending control is looking to have. So there's no hardware software changes to it, and so it's a very simple way to be adding this to an existing system. And now we're getting into more of our impact scale installations. It got to be a point where I really wanted, as I mentioned before, I build these to rent, and then I end up selling them. So it's like, rental is really nice. And so it's like almost like having something on the shelf if someone needs it right away. Okay, I get a rental here that's not available, that's not being used right now, you can have that one. But it also gave me a means of being able to test out a lot of what these scales do for me. Here, this is at MK Minerals. We just got here you're seeing 3 scales in a row. We just got order from Cargill for 6 at a certain processing plant. This is kind of interesting here. We're talking about a material calibration. How are we going to gather that kind of material that's passing through the scale? And so sometimes we get it at the end of the auger. But in this particular case, in the case that comes up next, I actually put a jam gate right below that. And so when we do our material calibration coming out of that silo, that auger's not turning. And material is then piling right through that into our weighing vessel. 5 more minutes? Okay, moving. Thank you. Appreciate it. So here's what we're doing the same thing here. And then we have, we're even doing stuff with dust. In this particular case, we got uneven amounts of dust coming into our process. But we want to smooth that out. We got too much. So we go through a surge bin, and there's a flow scale after, feeding our plant, and away we go. So these are more of those kind of things. This is another way to skin that cat that we were talking about there. We're batching out of this as a cement. And in this particular, we're doing some rock through there, but that's a really far shot, so we got to slow it down with the restrictor. We're doing grain with this as well. So these guys are doing seed cleaning. These guys are topping off a truck. I don't have a picture. This is of the one we did, but from that point they could top off their truck. Then during harvest time, you get all those trucks and all that traffic. Nobody has to be backing up from that, so that's important. That they get it topped off as close as possible. That's a big plus. Here are some things where the application here on the right did not work for them because they end up putting they were pneumatically, and consequently it was pressurizing things, where on the left there, this is how you really take care of that. This is another way here. They took this material should be going into a bag house, but they're just having that go into outside. This is our feeder scale. This is kind of interesting right here. We're putting our silo on load cells, and also that same silo's got an impact scale. Why would we do that? Well, on the next one right here, we can calibrate our flow scale right there as we're starting out production. And then after that, as production goes on, we know what is in the silo there. That gives it our bin weight, but also it tells us our impact flow scale rate. And also we can push a button after 6 minutes. Then we know that, what a tons per hour is, and that thing's right on the money. It is really worth its weight in gold. And how do we go about this? We need to have a flow scale or a impact, application data sheet, and get and have little drawings, and that gets us going down the way there. So anyhow, I want to thank you, Nisa. Thank you, Treasurer Secretary Michelle Safford, Program Chairman Jeremy Finnegan, President Matt Davis, all 4 directors, Vice President Ryan Fox. Thank you very much. I do want to say one little story here. I had so much fun with it. It was when we were at Savannah last year, and I was trying to be a big shot, and I'm seeing Central over here, and they had a table full of people. I said to my wife, Trish, I say, I'm going to buy these guys a drink, so I had the waiter come over, and then the waitress, and she goes over there, and I'm expecting to be buying them drinks, and a little bit later she brings me over a drink. I go, what's that for? Well, you asked them to buy you a drink. And it's been a really, so all 4 directors, thank you very much. Thank you very much, Kate Sameda and Colorado, and Tupper. Was nice that you were here. I really enjoyed that. You give me a lofty goal to keep on working towards. And then of course you might know these guys here, but you guys do know how to party. That's all I know. Thank you very much. I'm Clarence Richard. I'm a veteran. Have a good day.